Welcome to our today's lesson from pre-algebra class for the summer, and we are going to today review some integer work and rules, and we're also going to use that to interpret some order of operations problems as well. So that's kind of our goal for today. First thing we want to do is that we realize in our integer work, we need to first of all understand what integers are. And so we're going to make a really quick and brief summary of what integers are. And integers are actually part of what we call the real number system. And all the numbers that you will ever deal with are in the real number system. Within that, we categorize two boxes. In those two boxes, because this one's smaller, doesn't mean that there are fewer of them. It just means that we use them less often. Over here, what we have is what we would call our rational numbers. And so obviously over here, we would have our irrational numbers. And our irrational numbers, we'll take care of those first. They're the ones that we don't necessarily deal with a whole lot. Would be things like pi, square root of 2, square root of 17, something along those lines. Basically what irrational numbers are any number that goes into the decimal realm and continues on and on forever and yet never repeats a pattern. And so, for example, we know that pi, there's even big contests to see how many numbers of pi you can memorize. That's because it's a number that continues to go on and on and on. It never repeats a pattern. The square root of any prime number would also be that. If I type into my calculator the square root of 17, it will give me a decimal answer. And we'll think, oh, there must be a place where it stops. The reality of it is our calculator is just stopping it. It's rounding it off and giving us its closest symbol for it. So those are irrational numbers. We don't deal with those a ton, but we deal with them a little bit. But the main thing that we're going to deal with right now is what we call rational numbers. And a rational number, this is good for your notes, is any number that can be changed into a fraction. Irrational, obviously, then means it cannot be changed into a fraction. So rational numbers include also some other subsets within there. And our smallest subset of rational numbers are what we call natural numbers. Natural numbers, or counting numbers, are all of our numbers starting with 1 and going on and on and on and on. So it would be just like you and I would say how we would count for something. This goes 1, 2, 3, 4, 5, 6, 7, 8, on and on. Natural numbers are our smallest group. A larger group, just a tad bit larger, are what we call our whole number group. And our whole number group actually is the same as our natural group, except for it also includes the number 0. And so because it includes the number 0, that means that all natural numbers are also whole numbers, and all whole numbers are also natural numbers except for the number 0. Now, included in a larger group, those both are included in the group we call integers, which is where we're going to spend our time today. And in the integers group, that includes all the whole numbers and natural numbers, plus their negative counterparts. So I might have -3, -2, -1, 0, 1, 2, 3, ... So in other words, all of the whole numbers and all of their opposites or their negative equivalents. Okay, so this is just a quick rundown of what we have so far. Within the rational realm, all of these included, plus anything that can be changed into a fraction. And we know that whole numbers can be changed into a fraction simply by putting them over the number 1. So if I had the number 16 or negative 92, I could put those over 1 and all of a sudden it becomes a fraction. We also know that things such as repeated decimals, where we might have a decimal with a repeated sign over that, it seems like it goes on and on forever, which it does, but it also has a repeated pattern. And because of that, we can change it to a fraction. This one here would actually be, 3 over 9, which can be simplified to 1/3. We can go over more of that at some later point. But here's where we want to stay. We want to stay today in this integer realm in dealing with positives and negatives in the integer realm. And how do we add, subtract, multiply, and divide those? So as we go through today, that's where we're going to be talking about is integers. Now, most of you, if you're in this class, have probably dealt with integers already. And so hopefully this will be somewhat of a review for you. And in doing so, we'll hopefully be able to accomplish a lot in a little amount of time because it is a review. What I like to do is I like to start with multiplying and dividing of integers because I think it's the easiest. And so when we multiply and divide, there's a couple steps. All right? So multiplying and dividing integers. If you're taking notes, this would be good things to write down. Step 1, we just simply multiply and divide. That's pretty simple. The second step, we count up the number of negative signs in our problem. If there's an even number of negative signs, the answer is positive. If there is an odd number of negative signs, the answer is negative. And here's how that looks. We'll give us a quick little demonstration. If I have 5 times 4, if I have negative 5 times negative 4, if I have negative 5 times positive 4, and if I have 5 times negative 4, every one of those problems, the first thing I'm going to do is multiply. So 5 times 4, 20. 5 times 4, 20. 5 times 4, 20. And 20. Then I go back through and I count the number of negative signs. If I look at this problem, there are no negative signs, and so 0 negative signs would be the same as an even. So my answer is just 5 times 4, which is 20. If I come into this one, I have 1, 2 negative signs. 2 is an even number, which means the negatives cancel each other out. I end up with a positive 20 again. If I have a negative 5 times a positive 4, I have 1 negative sign. 1 is an odd number. Means my answer is also going to be negative. I have 5 times a negative 4. Again, 1 an odd number. My answer is going to be negative. I could do the same thing if I had division. All those in there, I lost one there, but we'll get the idea. We have a 20 over 4 is 5. There's no negative sign, so it stays positive. Negative over a negative. 2 negative signs means it stays positive. Negative over a positive means that there's only 1 negative sign. It's going to become negative. We could do that for our other one, which isn't showing up there. We have a positive divided by negative, which also gives us a negative answer. So all we do is we multiply or divide just like normal, add up the number of negative signs. If there's an even number, our answer is positive. If there's an odd number, then our answer is negative. Okay? Again, this hopefully should be a little bit of review for you. Next thing we're going to move into is addition of integers. In addition of integers, we have a little trick to hopefully help us. And what I like to think of it is same equals sum, and different equals difference. And if we know our terminology from math, we know that when something has a sum, it means that it's the answer to an addition problem. And when something has a difference, it means it's the answer to a subtraction problem. And so what I can do is I can take any addition problem in the when it includes integers. So for example, if I have 5 minus 4, excuse me, 5 plus 4, I have negative 5 plus negative 4. I have a negative 5 plus 4, and I have 5 plus negative 4. Well, what I do is I first of all, I look and I count the number of negative signs. If I'm looking at negative signs here, are there any negative signs? There are not any negative signs. So that means that they have the same sign. They both have a positive sign. So the signs are the same. It means I find the sum, so it means I add them both up. So what is 5 plus 4? It is 9. There's my answer. Well, hopefully we all know that one because we learned that one back in first and second grade. But if I look at this one, I've got a negative 5 plus negative 4. This is like I owe mom $5 and I owe dad $4. How much do I owe altogether? And again, I look at my signs. Both of them are negative. See that? So that means the signs are the same. They're both negative. If they're both the same, I find the sum, which means I add 5 and 4. Now, if I look at that, I also notice that both those numbers carry the same sign, which is negative, which means my answer also must carry the same sign. Then I go down to this next one, and I look and I say, well, there's a negative sign and a positive sign, means the signs are different. And so if the signs are different, I'm going to subtract. So 5 minus 4 is 1. Then I go back and I see which one has the larger absolute value. In other words, which one's further away from 0. In this case, 5 would be further away than 4. Well, 5 carries a negative sign, so that means my answer must be negative 1. I owe mom $5. I give her 4 because that's all I've got. I still owe her $1. Same idea, number of signs. There's one negative, one positive, means they're not the same, means they're different. Thus, I find the difference, I subtract them. 5 minus 4 is 1. Then I go back, is 5 further away from 0, or is negative 4 further away from 0? Well, 5 is further away. The sign that it carries is positive, so my answer is also positive. So what I've got is, I have $5, I owe Dad 4, I pay him back, I still have $1 left. Okay? So hopefully that makes a little bit better sense for you with addition. Now, I'm going to leave the adding up here, and I'm going to jump to subtracting here, because subtracting is the one where most people get hung up a little bit. and it gets a little bit complicated. So my suggestion, there's lots of ways to handle it, and lots of ways different teachers will tell you. My suggestion would be to change all of your subtraction into addition. And then just follow the addition rules. And the first thing that we want to do is we want to do a little thing called keep, change, oopsie, and change. Now there are more mathematical ways to go about it, more mathematical ways to understand really what's going on. But once we start to work through these, it will make a little bit more sense to you, and you'll be able to decipher some of that. The second thing is after I've done that, then I follow addition rules. Okay, so let's go by example through that real quick. So we have, using our same set of numbers that we were using, I'm going to say 5 minus 4. I'm going to say negative 5 minus a negative 4. I'm going to say a negative 5 minus 4. And a 5 minus a negative 4. Now, quite often, you will see that when you see these like in a textbook or something like that, they'll have these off in parentheses. Whenever I have two negative signs right next to each other, sometimes they separate them with parentheses. Does not mean anything new or unique, just means a different way they set them up. So if I follow my rules for subtraction, I'm going to do keep, change, change. And so here's what that looks like. I take my first number and I keep it. So in this case, it's 5. I change my minus to a plus. And then once I've done that, all I'm left with is the number 4. I change number 4 to its opposite. So what is the opposite of 4? It is negative 4. Then I can go back into my addition rules. Are the signs the same or different? Well, they are different. This one's negative, this one's positive, which means I subtract them. 5 minus 4 is 1. The larger of the two is positive, so my answer stays positive. Now, that's a long way about going to something you already know as 5 minus 4 is 1. But it's just I just want to show you it follows the same pattern no matter what you do. Down here, keep. First number is negative 5. My minus becomes plus. Then I have a negative 4. What's the opposite of negative 4? It is positive 4. And so negative 5 plus positive 4, signs are different. I subtract them. The larger is negative. My answer is negative 1. Hopefully you're catching on a little bit. I keep the negative 5. My minus becomes plus. The opposite of 4 is negative 4. The signs, I go back to my addition rule. The signs are the same, which means I add the two. The sign they share is negative. And then finally, my last one, I keep the first number, which is 5. My minus becomes plus. My change of my negative 4 becomes 4. So now I end up with 5 plus 4, which equals 9. Now, hopefully that's a good review of your integer rules, and you need to be doing some practice on those, because what we're going to start next is exponents. So next time you're with us, exponents are going to use these same rules in dealing with large numbers with large exponents. And so that's why we are working through them the way we are today, as a good reminder. All right, last thing, we're just going to take a couple minutes to review order of operations. In order of operations, just using those same integer rules in solving those. Reminder, our order of operations, we sometimes use the acronym of PEMDAS. And in doing so, we have parentheses, we have exponents, We have multiplication and division, which are interchangeable. And we have addition and subtraction, again, which are interchangeable from left to right. So for example, if I am looking at something that is using integers in the order of operations, I might say something like 7 minus 3 times, let's see, we've got 4 minus 5. First of all, anything in parentheses I do first. So that becomes 4 minus 5, which is negative 1. So now I have 7 minus 3 times negative 1. 3 times negative 1 is negative 3. Then I've got 7 minus negative 3. Here comes my integer rules again. Minus a negative means I keep the first number. My minus becomes positive. The opposite of negative 3 is positive 3. So what is 7 plus 3? Our answer is 10. All right? So you can see how everything we're doing right now is coming back to those integer rules. Let's take one more difficult one, and then we will wrap it up for today. So let's take this one. We've got a negative 3 to the third minus 6 times negative 2 minus 2. Now, if I look at this one, 3 to the third, obviously it's an exponent. This negative is not the same. So, for example, this is different than this. This right here says negative 3 times negative 3 times negative 3. This right here says 3 times 3 times 3 times a negative. Because it's got an odd exponent, we're going to get the same answer for that no matter what. But if it has an even exponent, which we can talk about at some other time, it would end up being the same, or different, I should say. So this one here is going to be negative 27 minus, what is 6 times negative 2? That would be a negative 12 minus 2. So here we go, negative 27, I keep, change, change, and that gives me a negative 15 minus 2. So I'm going to again keep, change, change. Negative 15 plus a negative 2 is going to give me a negative 17. All right. That just about concludes everything that we're reviewing in this last lesson. Please feel free to rewatch the video or pause it when you need to. One last thing I did want to just talk about, that is in the case that we have either fractions or decimals, and let's say we have something like this. We have a negative 4/5 minus 7/8. We'll go ahead and just drop that so it doesn't get confusing to us. I'm going to follow the same rules that I did before. I'm going to keep, I'm going to change, and I'm going to change the opposite of 7/8, which is negative 7/8. Now I know that both of my signs are the same, and I'm adding them, so it means I would add those both together because same means sum. And of course I would find my common denominator. I would add the two together. The common denominator in this case happens to be 40. And so I have a negative 32 over 40 plus a negative 35 over 40, which ends up giving me a negative 67 over 40. So our integer rules, even though we call them integer rules, they really would be called rational rules. They work for all fractions, all decimals that obviously have an ending to them and don't repeat, or do repeat. But they also, we think of them as our integer rules because that's kind of where we get our basis from. But we want to make sure that we are comfortable with those, especially as we hit exponents on our next lesson. And that way we can make sure that when we hit the ground or get there, we can hit the ground running with those. So hopefully that makes sense. And hopefully, like I said before, it was a review for you, but we can go from there and take off next week. Have a wonderful day. Thank you.